This video goes over homework on one sample test and measures of effect. Let's start with number 1. What is the Excel function for a one sample z-test? We talked about this in class. The formula or the function for a one sample z-test is called z.test. And remember that this does not give us a test statistic, it gives us the one-tailed p-value. So this result here is not my z-value, it's my p-value for that result. So that brings us to our next one. In Excel functions, what does the output from the one sample z-test represent? And it is our one-tailed p-value. Question number 3, for which of the following scenarios would it be appropriate to use a one sample z-test? So let's just go through and check these off. Comparing political affiliation of ASU students against the political affiliation of UA students. So that would be 2 samples. So we'd say no. Comparing the number of cigarettes smoked per day by residents of urban areas with the number of cigarettes smoked per day by all persons in the U.S. That would be yes, because I have a sample, and then I have population level information. C, comparing the average weight of newborns in hospital A to the average weight of newborns in hospital B. That's 2 samples, so that would be no. D, comparing the results of Likert scale patient satisfaction scores of patients at the VA against the Likert scale patient satisfaction scores of patients at General Hospital. So that would be 2 sample level information, so that would be no. So the only one here that fits is comparing my population in urban areas to the overall population, or my sample in urban areas to the overall population. Question 4. You have a sample of 45 males with an age range of 15 to 19, a mean height of 70.8 inches, and a standard deviation of 1.5 inches. What is the standard error of the mean? Okay, so let me go to my formula here and let me find the formula for standard error of the mean. And it's going to be my standard deviation divided by the square root of n. So let me get a scientific calculator pulled up here. And so I need to take my standard deviation, which is 1.5, and I need to divide that. I'm going to divide that by the square root of my sample size, which was 45. So I'm going to divide this by the square root. Make sure I can do square root of 45. And that's going to give me 0.2236. Okay, so use the following information for problems 5 through 7. And questions on the exam will be set up similar to this, where you have information and you need to run a test and then answer results answer questions based on those results. So the average birth weight of babies in the U.S. is 3,325 grams with a standard deviation of 525. A researcher wants to test whether or not a sample of 250 women in a rural community have a significantly different average birth weight at the alpha equals 0.05 level. Okay, and then it gives us our birth weight. So let's go ahead and just run our one sample test. And remember, we talked about how there's not functionality for this in Excel. So we would have to do it by hand or use a calculator. If you wanted to do this problem by hand, here is the formula that you would use for that. You would take your sample mean minus population mean divided by the standard error of the mean. And then we had just calculated standard error of the mean, but here's that formula. I'm going to use an online calculator for it. So I'm going to put in my population information, which is 3325. And then I'm going to put in my population standard deviation of 525. And then for my sample, my mean was 3,400. And my sample size was 250. My significance level is 0.05. It tells me that in the problem, and that's what this calculator defaulted to. So now I need to think about if I'm doing a left or right tail or both. And here I'm just looking to see if it's significantly different. I'm not looking to see if it's greater or less. I'm just looking to see if it's different. So I would do a two-tail test because I'm looking for either greater or less than difference. So let's go back to our calculator, check all of our parameters, and click calculate. Okay, so it gives me my results here. Let me see if I can make this a little bigger so hopefully you can see it. There we go. So I want to know what is the degrees of freedom for this study. And I know that degrees of freedom is going to be my sample size minus 1. It doesn't tell me that in here, but I know that from lecture. So my sample size minus 1 is degrees of freedom. So that's going to be 249. This problem asked me, what is my test statistic? And here I calculated this, and it gave me my test statistic, or z-value, as 2.2588. This is my test statistic. This is the value I calculated from my test by plugging my information into that formula and getting my z-value. So it's 2.588. Question 7. True or false, this finding is statistically significant? Well, to figure this out, I either need to compare my p-value to my level of significance that I set, or my critical value to my actual value that I computed, or my z-value I computed. So I'm going to use the p-value method because it's given to me here as part of my output. So my two-tailed p-value is 0.0239, and I'm going to compare that to my significance level, which was 0.05. My p-value of 0.0239 is lower than my significance level of 0.05. So that leads me to reject the null hypothesis and conclude that my test is statistically significant. If my p-value was greater than my level of significance, I would not reject the null hypothesis and I would conclude that it is not statistically significant. But here, because my p-value is lower, I would conclude that this is statistically significant. So for question 8, we have another block set of information here. And we need to look at, we have mothers who live in poverty have lower birth weight than women who do not live in poverty. The average birth weight for women living in poverty is 2,800 grams with a standard deviation of 500. Recently, a local hospital introduced an innovative prenatal care program to reduce the number of low birth weight babies born in the hospital. In the first year, 35 mothers, all of whom live in poverty, participated in the program. Program evaluators want to determine if the birth weight for infants who participate in the program is greater than the average birth weight for women who live in poverty. They choose an alpha of 0.05. The following data is the data in birth weight in grams for the babies born to mothers who participated in the program. So this makes sense, right? We want to see if babies that are born to mothers participating in this program are having greater birth weights. If we're putting a lot of money into this program and we're not actually seeing any results in terms of improved outcomes for babies, then what's the point of investing in the program? So we want to know if the program's working or not, if it's worth the money. So I have all the data here, which you can copy and paste. I also have the data as an Excel file, and when you click on these, it'll open it up for you. It'll just open up the Excel file. So use the data provided, information provided, and run the one sample z-test. Remember, in Excel, it's not going to give us the actual test statistic. It's just going to give us the p-value for that result. But that's okay because I don't need to answer the test statistic. So let's go ahead and just run this in Excel. If I wanted to use an online calculator, I would need to figure out the mean for this sample first for most of the online calculators. So I could figure that out and use an online calculator, but I'm going to do this in Excel. So let me get the function for the z-test here. And I need to tell it where my data array is. The other thing I need to tell it is my population parameters, which I got from the problem. I can either type them into this or I can have them already typed into my sheet somewhere and click into it. I'll just go ahead and type it in. So my population information is 2,800 grams and a standard deviation of 500. So 2,800 and 500. Okay, so that gives me a p-value of 0.0044. because remember, this result is my one-tailed p-value. But let's go back to the problem and just answer questions in order. So first, how would I write the null hypothesis? So my null hypothesis is that there's going to be no difference. It's going to be the same. So it's going to be that my population mean, that the mean birth weight is going to be equal to 2,800 grams. That's what it is. It's not going to be different. My alternative hypothesis, I can write a couple of ways. I could write that it's just going to be different. But in this case, remember, I'm wanting to see if the birth weights are actually increasing to justify the expense of this program. If the birth weights are actually lower from others who participate in this program, then it definitely wouldn't justify the expense. So I want to look to see that the birth weights for women who participate are going to be increasing. So I'm looking for the birth weight to be over 2,800 grams. I want to see improvement. So this would be the hypothesis that makes the most sense. You decide the alternative hypothesis conceptually based on what makes sense. And in this case, it makes sense to look at whether or not the birth weights are improved. So that's what we would use for our alternative. Question 10 asks, what is the p-value for the one sample test result? And we ran that test and got a p-value of 0.0044. So 0.0044. True or false, this finding is statistically significant at the alpha equals 0.05 level. So I'm going to compare my significance level to my p-value. My significance level is 0.05. My p-value is 0.044. So this is my p-value. This is my significance level. My p-value is lower than the level of significance, so I'm going to conclude that my test is statistically significant. If it's higher than the level of significance, I would conclude my test is not statistically significant. But my significance level I set is 0.05, and my p-value was lower than that at 0.044. So I conclude that this test is statistically significant. True. Based on this information, the researcher should make the decision to, well, if my test is statistically significant and my p-value is lower than significance level, and I'm rejecting the null hypothesis, I'm concluding that there is a difference between my two groups, and I reject the null hypothesis of no difference. So if my p-value gives me a statistically significant result, I would reject my null hypothesis. Question 13. Based on this information, the researcher should conclude that pregnant women who live in poverty and participate in the prenatal care program have infants with blank birth weights than women who live in poverty and do not participate in the program. So putting this back into terms of what we were studying, we were looking to see if the birth weights would be the same or if they would be increased for women who participated in the program. So what we found was that our alternative hypothesis, that birth weights were increased, was going to be upheld because we rejected the null hypothesis of no difference. So we found that people who participate in the program had infants with higher birth weights than women who lived in poverty and did not participate in the program. Question 14. A blank is a statistic that measures the magnitude of relationships between variables. So a t-test is a specific type of test. A measure of effect is going to measure the magnitude difference between variables. Confounder is going to alter that, but it doesn't measure, it alters the relationships, but it doesn't measure them. And the p-value is the probability that my null hypothesis is true, or that I would get my results if the null hypothesis is true. So here, this is a measure of effect. It is going to measure the magnitude of the relationship between my variables. Question 15. If you want to explore the magnitude of the difference in the means between two groups, which effect would you use? Okay, so we talked about in class for one sample test, but we would use a Cohen's d, and that's also what we're going to use with the two groups, because one group could be a sample and my population, or it could be two samples. So for both of those situations, we're going to use Cohen's d as to look at the difference in means. Pearson's R would tell us the correlation between two variables, right? And if I'm looking at a difference between two groups, my Cohen's d is going to compare that. Question 16. Which of the following is not true about measures of effect? A, there are many different types of measures of effect. Well, we talked about that in class in the measures of effect slide, that there's lots of different measures of effects for different tests. So Cohen's d is one of them. Correlation's one, Kramer's v is another. So this is true. You can compare measures of effect from different studies with the same outcome measure. So as long as the study was looking at the same thing and used the same type of test to do it, we can compare those across different studies. So that's true. They aid in the interpretation of statistical results. That is true because we can take multiple studies done at different time periods, kind of pool those results together to make a decision. So that's true. And then D, they are extremely affected by sample size. This is not true. So even though the actual test statistic that might have been calculated took into account sample size, my measures of effect formulas do not take into account sample size. They take into account the magnitude of the difference between the groups. So they are, sample size figures into it a little bit, but they're not extremely affected by sample size, which lets us compare from a study with a small sample to a study with a larger sample. So that lets us compare across different types of studies with different samples and different numbers of people in them. So this is false. Measures of effect are not extremely affected by sample size. Okay, and that is the homework on one sample test and measures of effect.